So at this point, what I've gone through is 5 different myths associated with software sustainability, and tried to give you some examples of why these myths are really not pointing towards true aims and objectives of software sustainability, but delving a little bit deeper to understand where they came from, what the grain of truth is in each of them. Obviously, it wouldn't be very good for me just to explore the myths and not try and show some examples where I think there's been successes. So the other thing I want to do is introduce 5 heroes of software sustainability. And look at the different things that from the projects that I've been involved with and worked with seem to have made the biggest impact in terms of success and carrying on different pieces of software. So the first one, and I'm not going to try and pronounce the name of the goddess of memory here, is to remember about your users. So this is kind of going back to what I was talking about earlier and understanding our user base. I mentioned earlier that we had collected different quotes from interviews from something called the Engage project. The second part of the Engage project was interesting in that what we did was carry out a larger part of the cycle, going from the set of interviews and understanding the requirements from lots of different researchers across the UK to creating a set of projects based on these requirements, and then disseminating the results of these projects. So in some way kind of going towards what Malcolm was asking about, trying to grow the mind share. And then taking that background and creating further adoption, because the more people that know about something and the more people that can connect with something, the more likely they are to use it, which in turn creates new requirements. And ultimately completing this cycle by creating new projects. So what we have ended up with is a cycle which goes from an initial idea through to something that's implemented, through to something which is spoken about, and all the way around in terms of gradually building up your community. So each time around the cycle, you get more people interested, you get more people involved, and you get more people asking for the project to do something. And all of this really creates not just a wider mindshare, but wider deployment. And one of the aspects, I think, of software sustainability is if you can understand your users and you can understand how your community thinks, you can respond properly to that and you can build up trust. Did you have a question? So an example here is the way that my experiment has been undergoing its original sort of development cycle. So my experiment is it's both a piece of software and it's a website that allows people to store digital research objects. It started off by being something that allowed you to store workflows, but as it cycled through, it's sort of as it's created new development releases and it's taught to its user base, things have changed. So as it's gone on, it's gained new users. It started off being very much aimed at the bioinformatics community. It now has people from the astronomy community using it as well, particle physics. As it's gone on, it's not just been looking at workflows, but it's been finding out what makes other pieces of software not fit the needs of its current set of users. So why is this different from something like another repository software, sort of general repository software like Fedora or DSpace? It started to look at things like licensing, like understanding how to create links between different objects that are meaningful to the particular sets of users and communities that are using its software. So what it's been doing is it's been doing the cycling in conjunction with its user community. And importantly, it's been getting its user community to contribute back. Not just ideas, but also extensions. So that's one example here, again, of something where you have to do that cycle and make sure that the community, the research community, and the people who are developing the software never get too far apart. I think it's interesting, actually. When I was trying to find examples for this talk, There are an awful lot of projects that are, there are lots of examples in the text of projects which have failed from the start because they've not addressed user requirements. And they've done it in such a way that by the time the first project cycle is finished, the software does not meet the needs of its users. There are not as many examples of something where it has been successful, but then the communities have drifted apart. And yet, I think that is the case. So it would be interesting, perhaps, if any of you have ideas or have had experience of this, to discuss this after the talk is finished. The second hero, understanding the value. So I mentioned that one of the things that was common in a lot of the Engage projects and things like my experiment was an understanding of what was valued by the community that the software was meeting the needs of. Another good example is the work that's been done by people like Jim Austin's group down in York, who have managed to take an idea of how to use software to monitor different kinds of, essentially looking at electrical impulses, initially in something like an aeroplane engine, and using it to understand how to diagnose potential faults, understand when maintenance cycles need to occur, and generally making the diagnosis of aero engine failure more efficient, and taking that software and using it in something which you would at first kind of guess, think had absolutely no connection, but actually has the same requirements. So this isn't kind of skirts and trousers. This is two different sets of people wearing the same kinds of skirts. So looking at it in the Carmen project, and Carmen is looking at understanding how the brain works, so neuroscience. And instead of connecting up your wires and your sensors to parts of aeroplane engines, they're connecting up these wires and sensors to people's brains, and understanding whether or not the way that the brain emits signals can give us some idea of how it works and whether or not we can, again, understand failure modes. So it looks like a very different piece of software, but actually what the group has been very good at doing is understanding the value in the software they created initially. And that value was in a tool that allowed them to explore different types of signals in real time. And that's something that has a use in lots of different communities. The other thing they did, which comes back to one of the examples I gave earlier, is that they didn't just turn it into a general tool, but they repurposed it. They ported it over and made it into a specialist tool based on that existing tool for the new community. So I think that's also very important, that whilst you need to understand the value, you also need to understand where you need to, I suppose, people like to see different things. So when you are trying to, if you're a salesman and you're trying to compare two different cars or two different computers, people will buy things based on different characteristics, even if they do the same job. So again here, it's understanding what is it that will allow people to make the right choices and make sure that they choose something that will both work for them, but also meet their needs. And sometimes that's about understanding how to present the piece of software. Another example here is a piece of software which looks at different types of public sector data and pushes it together. So what's the value in here? The value in this example, which is from My Society, is not about the software itself, actually. It's understanding about the different ways in which the data can be visualized. So this in particular is an example of all of the places where you can live where it's quicker to use public transport than it is to use a car